So, ladies and gentlemen, I hope this thing is working and I can be heard. We have 2 minutes to go. I welcome you to this session on rangelands, pastoralism, and greenhouse gas emissions. And the narrative always, or very often, goes that extensive rangelands used by pastoralism can hardly be used for other agricultural purposes. Nevertheless, there is a large pressure on that land and conflicting claims on it. But on the other hand, it's used by mobile pastoralism in many parts of this world since a very long time. And on the other hand, again, there are those claims that ruminant production is associated with a lot of greenhouse gas emissions. And we have compiled this session so as to hear different voices on these topics and see what is actually sort of the state of the art. What do we know about greenhouse gas emissions, about footprint, about pastoral strategies? Because to my understanding, we do not yet understand these pastoral mobile systems sufficiently enough to devise policy recommendations and guidelines that would permit a framework to best exploit the potential that is harbored in these vast areas operated by these systems. And so the first speaker for today, I might invite to the front, it's Ms. Glarian Isiaho, and she'll give us an overview, starting our story with assessing Africa's environmental footprints, unveiling cattle production variations across regions, so to say, as an opener. I'll hand you the microphone. The floor is yours. You have 10 minutes.
Good afternoon, everyone. My name is Larry Michelle. I work for International Biological Affairs under the Tropical Forages Networks. Today I'm going to present about assessing Africa's environmental footprint, where we are looking at cattle as across various regions of Africa. At this level, you're going to look at the introduction part, where we are looking at, it is approximated that the demand for animal products that is meat milk in Africa is growing very much and is expected to triple and double in the next coming years. So this demand is causing a lot of stress in natural resources, including depletion of water. We also have effects on land and as well as effects on water. Therefore, it is imperative for us to look at the regional environmental impacts, especially of cattle production in Africa. Some of you might be asking why cattle. It's because according to the latest statistics, cattle is approximated to be about 383 million in Africa. It was a systematic literature review that was carried out with the objective to analyze the differences in cattle production efficiency and the resulting environmental footprints. So the review followed the transfer and others methodology that was done in 2003, where we had planning of the review, conducting of the actual review, and lastly, presentation of the results from the review. From the first pool of studies, we got 158 papers after the first screening. And then after the second screening, we got 100, I'm not sure, but from that 158, there was 121 journals, 9 books, 6 section books, and then we have 5 conference proceedings and 17 cases. We have the bibliography databases as shown in the slides. So the conducting of the review, we consider metrics as follows. So we had 6 categories. We were looking at productivity of cattle, where we were looking at both dairy and beef. So dairy, we were looking at the kilograms of milk per cow per year. And then for beef, we were looking at the daily live weight gain per animal. Then for the greenhouse gas emission intensity, we were looking at the kilograms of carbon equivalent of protein corrected milk. And for beef, we were looking at kilograms of carbon equivalent per kilogram of meat. For the water usage, we were looking at the meter cubed per fat and protein corrected milk. And for beef, we were looking at the meter cubed used to produce a kilogram of meat. For the land requirement, we were looking at a hectare of producing a kilogram of fat and protein corrected milk, and for the meat, we were looking at hectare of producing a ton of meat. So from the second screening, we came to 112 publications, which were included in the review according to the eligibility criteria. So the results and the dissemination of the results are as follows. So the Africa was divided into 5 regions. That is the north, east, central, west, and the south. And then we looked at productivity and the subsequent environmental impacts on environmental footprints. So from the table, we can see that South Africa was the best performing region. As we look at the productivity, you can see that the minimum regional productivity was about 1722.8, which is more or less more than most of the minimum in other regions. And also, if you look at the maximum, South Africa also had the maximum amount of productivity of milk per year. And subsequently, that brings about to less environmental impacts or environmental footprint. If you look at the greenhouse gas emission, in South Africa, we have the least. And then if you compare South Africa to West Africa, which was the worst performing in terms of dairy production, we see that South Africa had a minimum of 1.1 and a maximum of 1.8. As opposed to West Africa, where it had around 12.8. I know maybe you're looking at East Africa and you're wondering, like East Africa had a maximum of 23.8, but if you look at the productivity is quite high compared to West Africa. The same to water footprint, you see South Africa is also doing much better than other regions. Where we do not have data, the studies did not qualify according to the eligibility criteria, so we don't have data for other regions. The results for productivity and environmental footprint of food cattle. So in this case, we see that North Africa is doing much better than other regions, with a maximum of about 0.95 in terms of kilograms per day. And then if you look at greenhouse gas emission is quite low, a maximum of about 11.5. But then East Africa, on the other hand, is not doing that great. If you look at the maximum greenhouse gas emission is about 144.4. That is way too much. If you look at the productivity of East Africa, it's also on the low end with a minimum of about 0.31 and a maximum of about 1.17. So to conclude this, we have a lot of high numbers of cattle in Africa, but the problem is that the productivity rate is very low. We can see that from the tables, intensive systems are the most productive system. This is in comparison to semi-intensive and extensive production systems in Africa. We can also see that there is a lot of high or more greenhouse gas emission intensity, water and land footprint in Africa. And this can be attributed to so many other things, but just to mention a few, we have most of the African systems are dual purpose in nature. They are not specialized so much in terms of either dairy production or beef production. Most farmers opt to do both, and that brings a lot of high emission or high environmental footprints. Another reason it can be attributed to the low quality feeds in Africa, and as well as limited access to veterinarian services. Additionally, we also have poor animal husbandry practices. There is a lot of room for improvement in Africa, and we can adopt a lot of changes. For example, we can implement smart agricultural technologies, and also we are also recommending that we move from the ordinary extensive production systems to intensive production systems, as well as also we can also have an adoption of silvopastoral systems in Africa. So that's it. Thank you.
Again, to scan the vast body of literature across Africa and across different production systems, and I bet there are questions. Sonia.
Thanks for the interesting presentation. I have a couple of questions. Maybe we can clarify some after the session. Just to your last point, you suggest that extensive systems should become more intensified to reduce their environmental footprint. But then extensive systems are often found in marginal regions, semi-arid areas that are too dry for crop production, land that is not very productive. So how do you suggest that these systems could be intensified? And also, what are potential trade-offs of intensification, such as soil carbon loss from land conversion, for example? If you could comment on that.
Well, from the review, that was just one of the suggestions, that you can move from extensive systems, because from the review, you can see that extensive systems have high environmental footprint. But then, considering that you mentioned about dry or marginal areas, I think one of the recommendations would be adoption of silvopastoral systems, which sort of lowers some of the environmental footprints like greenhouse gas emission. That could also work in that case, because you cannot expect every system in Africa to be intensive or semi-intensive.
Yeah.
Thank you. I have just a comment or two, not really questions. I think it would be good to your overview to indicate whether the system, especially when it comes to the extensive systems, is mobile or semi-mobile or sedentary, A. And it would also be good to know N, the number of publications behind your data for interpretation. Yeah? That would be really helpful.
That was also my fault. Have you got an indication on how many papers you had on the intensive, the semi-intensive, and the extensive, and an assessment of how solid the data in the respective papers were. Your impression?
Yeah, that is a very good comment. I have the numbers, but I did not put them on the slide. We can put, like, the slides will be too many, but the numbers are there. I cannot really remember every value, but I can put that into consideration, and maybe I will share with you after this meeting.
Yeah, mine is rather a comment than a question. I think to see the clear picture of the environmental footprint, maybe would have scaled those values by the sizes of the different regions. Yeah, because we are looking at the footprint. How do you see that?
My sizes, what do you mean?
Land sizes, for example, and available production, water for production. Because you are looking at the footprint of the environmental footprint in the different areas. Okay?
Yeah.
But the different areas have different sizes. West Africa will be smaller than Southern Africa.
Yeah, that is true. But during the review, we did not consider sizes, but we considered how the United Nations have divided Africa into regions, not considering the sizes, honestly.
That would have been another comment also from my side. How are your productivity measures that you consider? I saw on one slide, kilogram beef produced per day, 0.31. Why is productivity expressed per day and not maybe per kilogram feed intake or something? So there's certainly a lot of things that one can do differently or consider otherwise. And the data in the publication, I appreciate the hard work. The data is probably not so homogeneous that it can all fit well into one review. So congratulations on what you have achieved and shown us. Thank you for your presentation and for this. Now we will have 3 examples from different mobile pastoral systems throughout the world, or not throughout the world, throughout Africa. And the first one is from Namibia, and I invite Wilhelmina Mule to report to us on cattle behavior when grazing extensive areas in northern Namibia. Wilhelmina, it's yours. Pointer. Did you go? Yes.
Hello everyone, my name is Wilhelmina and I'm doing my PhD with the German Institute for Tropical and Subtropical Agriculture. I'm going to take you through my research on cattle behavior and leader support strategies, a study of mountain grazing in Kunene North, with the Kunene North pastoralists. Just some background information. Pastoralists had their livelihood grazing herds on communal rangelands, and these rangelands are characterized by high temporal spatial variability in forage and rainfall. So the grazing habits of livestock plays a significant role on the health of both the animals in the rangelands, and the grazing success of cattle depends on how the header interacts with his herd and also how they interact with their environment. The issue that led us to conduct this study is the dry season and drought reserve pasture areas are usually located in mountainous rocky areas that are usually far from waters and also difficult to access. So for the cattle to gain access to these pasture areas, they need support from a very skillful header. But however, our understanding on how these interrelations between the humans, their animals, and the environments influence on the production outcome of the system is limited. The study was conducted with the Himba pastoralists in Kunene North, And for this pastoralists to ensure that there's continuous availability of fodder for the animals throughout the year, and also to allow sufficient recovery of the pasture areas, they have divided their rangelands into three zones. We have the wet season grazing areas that are usually in the flatlands, close to water and settlements. And then we have the dry season here, the dry season grazing areas that are usually in the mountains and rocky places far from water. And then we have the drought reserves that are in high mountainous rocky places and very far from water. The annual rainfall in the region is about 250 millimeters, and there are some years of drought that are usually critical for livestock survival. We conducted this study to identify the interactions between the headers, their cattle heads, and their rangelands from their own perspectives. And then we also wanted to investigate the factors that influence the cattle behavior associated to mountain grazing. We did this through semi-structured and narrative interviews, and with the Himba headers, and we gathered information on the cattle head composition, families, and traits, on rangeland use, as well as their heading practices. Our results here show the three common breeds that we find in the area. We have a Nguni breed that is well suited to the area, but it has a small body frame and also has low milk production. Then we have a Brahman that usually comes in the area from the commercial farms, and it is not well adapted to the conditions of Kunene, but it has a big body frame and also has good milk production. Then third, we have a breed that is locally called the Herero breed, and also not well adapted to the area, and it has a big body frame, but also high milk production actually compared to the first two that I mentioned. So the two big breeds now that are current in the areas usually die during the areas during the years of drought, when the rainfall goes below 150 millimeters. But the headers still, they keep them because drought only occurs once in 7 or in 10 years, 12 years. So for the years that you do not have drought, you still get to enjoy the benefits of these big breeds. In a herd, you may find a combination of different breeds, and this is closely linked to the landscape. For instance, in the highly mountainous rocky places, you find a high percentage of the Nguni breed. And as you move to the places with flat mountains that are easier to climb, then the percentage drops, and then you find now other breeds or the crosses between the indigenous breeds and the other two breeds. Any mountainous area actually has obstacles that restrict the movement of animals or to access these pastures. And the headers in the Kunene region like animals that are able to do the grazing activities on their own. By grazing activities, I mean that are able to reach the pasture areas by themselves, that are able to go to the water points by themselves, and also, especially for the lactating cows, the ones that are able to come back home to its calf on its own without the header's assistance. If the animal is not able to do this on its own, they consider it either stupid or lazy or too weak or so. And here are some of the factors that limit the animals to access their pastures, the dry season grazing pastures on their own. First, we have the cattle breed, and then when we look at our three breeds, the Nguni breed, as I said, it is well adapted to the area, can climb mountains and walk well on rocks, so it's able to reach the top of the mountain by itself, and then the header is heavy. We have a Brahman breed that fear walking on rocks and also fear steep slope. So it can only go up to halfway of the mountain. So if wherever it reaches, it's not able to, there's no pasture, then the header is not ready, so he needs to assist it. And then the header breed usually does not climb on its own. So it always rely on the assistance from the header. And then apart from the breed, we also have other factors, like the experience of the animal to the area. So if the animal is new to the area, doesn't know where the pasture areas are, so it always needs to be shown. And also the mountain climbing experience. If the animal does not know how to climb the mountains, then it also needs to be trained. Another factor is the body condition of the animal. If it's weak, then it doesn't have the strength to climb on its own. Here we have some of the strategies that the headers use in assisting their animals. We have, we divided this into, we have if the animals are new to the area or new to the mountain climbing, so they use the dung application method, where they apply the dung of the cattle on the rocks as you go up the mountain. So when the animals smell this, they assume that others usually passes here, so they are motivated to keep going. And also the header may focus on training the lead cow. Usually there's this cow that is always ahead of the others. It's usually have a good memory, and it's also very clever. So the header will usually now keep doing training, showing it, and training how to climb the mountain for instance for a week. And then after that, he just shows the direction, and then it will go, and then the rest of the group will follow. For other animals, for instance, the ones that are weak, you consider evening climbing, where your animals are watered in the afternoon, and then they allow to rest, and then in the evening when it's cooler, that's when you can make them climb, because during the day it's exhausting, and going uphill is also difficult. And then you also consider creating beds. As you can see in this picture, you can move the sharp and big rocks so that it's a bit easier for the animals to walk. Moving them slowly. If somebody is very irresponsible, then they want to be somewhere else with their friends, you might rush them, which may make them now maybe fall and get injured. So moving them slowly so that you also don't get them tired if they are already weak. You can also use an easier slope if possible, considering the breeds that fear walking, fear steep slope, and then also head split. You split your head into the two groups, the stronger group and then the weaker group. So you had the weaker groups on the mountain that is a bit easier to climb, and then the stronger groups, since they still have enough strength to climb, then you allow them to go to the higher mountains. In conclusion, we just want to say, we'd like to conclude that the combination of the header skill and the capabilities of cattle enable them to use these hardly accessible pastures, and therefore these animals survive the critical conditions. And also in the choice of the cattle breeds, the Himba pastoralist trade-off between the production output and then the ability to use these available resources. The way the header interact with their cattle and the way they interact with their rangelands highly influence the livestock production and the human livelihoods of this pastoralist. Finally, thank you so much for your attention. And I would like to thank the pastoralist in Kunene North, my research assistant, Seth and Biko, and the DFG for funding this research.
Thank you, Nina, for an insight into an intensive system that doesn't probably lend itself easy to intensification. Do we have questions, comments? Mark?
Just a practical question to develop the herds with the positive traits. So is there any kind of attempt to crossbreed so that maybe the good traits and properties of the one breed is combined with the one from the Ngoni, so that there's a kind of improvement in breeding?
Yes, so much. It's only that I cannot show the whole work. But then that is actually the idea, because they want to keep the Nguni in terms now they drought, they are able to survive, and the other breeds now to produce milk and then a lot of milk. But then the intention is that maybe you get a Brahman breed while you have your Nguni cows, and then you cross so that they have now this good traits also. So it's able to climb the mountain. This cross is able to climb mountains. It also has some milk. Not more, not a lot as the Tua Brahman, but also not less as the Bianca. So this is their idea actually to crossbreed, and you have this process.
Thank you very much for the interesting presentation. I'm wondering, from other pastoralist communities in Africa, we know that they really, once there is new offspring, then they train the young ones to do certain things which are really something they don't inherit it necessarily, but they are trained to do it. So is there any experience within the Himba community that the offspring of the Brahman or from the other the exotic or other breeds learn it when they were born there?
Yes, that happens because other options when you speak to other people not from the area, they are saying that since these the bigger breeds are slower, they tend to graze them separately. So the Ngunis are faster, so they are grazed separately, and then these big breeds are grazed separately. But then what the Himbas do is that they graze these two breeds together so that they learn from each other. And usually the lead cow is, in most cases, it's the Himba, so it's also pulling the other heads, and then the other crosses also learn. So through them being grazed together and working together, so they also learn something from the other heads. But this training also now that I explained, it also involves all the other, from a younger age, the calves are already being trained on how to climb the mountains.
One last question, thanks. One over here.
Okay, I would like to know more about the Herero breed, because to me it looks a bit suspicious. You had about 100 years, or a little bit more, of Namibian history, where the emphasis was on replacing indigenous animals. And the Nguni that survived, so also survived in South Africa. But you had a strong emphasis on replacing these animals. And there are certain traits which are not adapted, which are unfavorable for the environment. And therefore, it looks a bit suspicious to me.
I'm not sure if I get the question. The question was?
The question is, he is doubting that the Herero breed is actually something really indigenous and original.
It's not anything.
Huh?
It's replacement.
It has been replaced by 100 years of breeding through colonial times, isn't it?
Thank you.
Or 120, yeah, whatever. Huh? And so, but what is your suspicion about the breed?
Okay, maybe I explain the breed is locally called a Herero breed, but then because it comes from an area called Herero land. It's so when it gets in the area, they get to call it a Herero breed, but actually now we are also planning of looking into the DNA to see exactly what type of breed it is. But so far the headers call it a Herero breed, and maybe it's a combination of different breeds that are bigger, or we still have to look at it, but we get to call it a Herero breed because of the way as we said, it's from the basic tips of the headers themselves. don't call it that way, but as we go on, then we look at what exactly is this breed.
Yes, thank you very much, Wilhelmina. The next example takes us to a mobile pastoral system in northern Kenya. I welcome Malit Wako to introduce us to a comparative analysis of rangeland governance among two pastoral communities in northern Kenya. The floor is all yours.
Thank you. Good afternoon. My name is Malit Wako, and I am a PhD student at the German Institute for Tropical and Subtropical Agriculture, and today I want to talk to you about the rangeland governance among two pastoral communities of northern Kenya. So as we all know, rangelands cover almost 40% of Africa, but in Kenya it's even higher, at a higher percentage, 80. And pastoralists now use mobile land use to ensure, they'll use mobile land use to ensure that they harness these resources. So within Kenya, the rangeland of governance, it follows two outlines: the legal structure of the country and the community-based laws and regulations. And within Kenyan rangelands now, most of the time it's based on community-based rangeland governance, where it regulates access and use of resources. And recently now, rangelands have been having increased competitions that is driven from conservation, green energy, and carbon projects. This means that there is increasing loss of grazing lands, and therefore there is restrictions on livestock movements, and therefore this means there is increased pressure on community rangeland governance. So it is important for us to understand and recognize the systems that are governing these rangelands, and it's important to understand this so that such knowledge can be taken into considerations by policymakers and external actors during implementations of such investments. Therefore, the aim of this study was to analyze rangeland governance structures and practices among two pastoral communities in Marsabit County in Kenya. And this was conducted in Sololo areas. And this is the Sololo area. Within Borana community and the Laisamis area. This is within Rendile communities, and our research was guided by three research questions, where first we wanted to understand what pastoralists perceive as their resources and how they use them, and who decides on how, where, when, and who uses rangeland resources, and how different actors are linked. And then we also wanted to understand what are their practices when it comes to governance. So to understand our first research questions, we carried out our community participatory mapping with pastoral communities from both areas. And then for us to understand now who decides, the main decision makers, and also some of the practices, we carried out a net mapping tool sessions where our lead questions were: who decides where, when, and how rangeland resources are used? How are the different actors interacting, and what are their level of influence when it comes to rangeland governance? This was also carried out in both communities. So as a result of our first data collection method and community mapping, what we found out was that pastoralists have knowledge of their grazing lands, and they classify them according to different names and different uses. And just to zoom into what this means, what kind of information. This is one of the grazing units I'm going to give you an example of, where you see that they classify it as a seasonal, a wet season grazing unit, and it's usually during wet season where animals graze in this unit. You find that the body conditions of the animals improve quickly, and it has different. It has vegetarian species. And then another example we see here. This is classified as a drought reserve. And it has different common grasses and trees. And it's a very important unit because it's around settlements and a permanent water source. Another example is the Goturo. These are the local names that the different grazing units are known for. So this unit is used for both wet and dry season, and it has common trees that are important for camels. But unfortunately, you find that it has also some vectors where this information that we found within different grazing units that pastoralists use is that this is common knowledge for them. But when it comes to the images of satellite, it's not available on the satellite. So any external actor or anyone who is outside this region might not have this kind of information unless now you go and do the mapping with them so that you better understand how they see it and how they use. And then for our next research question was on who decides. So our first decision maker and the most influential that we found were the community elders. And at the Rangeland unit, the larger unit, they are the main decision makers. And then at the village level, we found that there was a head of a village who was also a strong decision maker. And then at the household level, where they make decisions on their own livelihood, on their own livestock, there was the head of household who will the red lines means the interaction here is informational flow. There are different informational flow between the three actors, but for the livestock owner, you find that he's interacting with his wife, making decisions based on their own livestock. And then we have the herders and also the scouts, who are the main information source of where they migrate next to. And then we also had other actors who are of importance when it comes to other resources. These were when it came to water sources, there was a water manager, water management committee, there was a shallow well owner, and when it came to grazing, we had environmental management committees. And this, most of the interactions was in terms of information, but there were also other interactions in terms of the blue. They were given directives. There were the different water actors were given directives to the community elders. The community elders gave directives to all the other actors. So just to give you an example of some of the practices. When accessing permanent water sources, pastoralists, first of all, the first thing is that during the wet season, the only source of water that they use are the temporary water sources. This will be the paddles, the natural catchments, and within this, when it comes to governance, there is no regulation, and the rule is that all the other sources are closed. And then once the water here depletes, the herders will approach now the community elders to ask for the next, the semi-permanent water sources to be opened. And then the decision makers will put in charge a water manager to oversee the running and regulations and use of the sources. And now the semi-permanent water sources will be used during the dry season. And the regulation when it comes to governance is that you can only use this once it's open. Before that, you're not allowed to use, and they follow a procedure of drinking, and they also need to clean up after their animals to ensure that the cleanness is maintained. And then to move on to a permanent water source, the same thing happens. The herders will request for opening of the sources. And then the elders will put on an actor of a water management committee, a borehole operator, and then they access the boreholes. So boreholes will be used during times of stress or droughts or prolonged seasons of dry seasons. And then here, the animal species also drink in a specific order. And if the season is too stressful, then animals will be drinking 2 to 3 days apart. And then back to our actors. The other important actor that was mentioned was also the chief,
who is the link between community and the government. So anything that the community elders cannot handle at community level, or it's something that goes beyond their roles, it's passed on to the chief, and then the chief, anything that he cannot handle at his level, he passes on to he escalates it to other bodies that are higher than him. And then other actors that were mentioned were also Ministry of Livestock in case of disease outbreaks. They come in with mass vaccinations. And then these are the non-governmental organizations who most of the interactions you see are support that they give communities. And then the ward administrator, this guy is at county level because Kenyan government is divided into two. So what this tells us is that governance in rangelands, it follows a set of procedures and it has different actors and they have different roles. So in conclusion is that pastoralists, as most of policymakers and external actors, all they see in rangelands, it's like a huge land that is just being used. But for pastoralists, it means something. They have knowledge of the different attributes. They have knowledge of how, like, what features it has, and they classify them into different uses. And this is knowledge that is common to them, and it's passed down to younger generation as well. And then when it comes to rangeland governance, there are different structures at different levels who are assigned different roles to ensure that the resources are used sustainably. And then, so by ensuring that you bring light to the different procedures that are followed to ensure that resources are used sustainably, then policymakers or external actors can appreciate the legitimacy and they can take into consideration some knowledge with their making decisions. Thank you very much for your attention.
How heterogeneous resources can be and can be perceived, and for trying to unravel how decision-making in these systems may function. We have questions. Michael.
Thanks for the excellent presentation. Congratulations. What happens during drought? When things become tough, are these institutions stress resistant? Are they sufficiently resilient, or if not, what changes? Look at the most recent droughts we had in Kenya.
So when it comes to droughts, there are different, again, processes that goes on. So in case, say the drought in the Borana area hits worse than maybe lower areas where Boranas are, which is maybe Isiolo, then community elders will then again come and talk to elders within the different regions. And then they will be either allowed to come in to use, and if they assess, the community elders usually just assess if the grass is there or the water sources are enough for everyone. If it's enough, they let them come in. If it's not, they tell them, unfortunately, it's not possible, you move on to, they recommend them to a different area where there's enough grasses. So usually there's still procedures to look at this.
And another one by Niels first.
Maybe just that, in addition, you saw the peace committees being mentioned. That is not for nothing. So these negotiations are not always very simple. And depends on the power distribution, how they get resolved. My question is a little different. You presented a very straightforward situation. Although you collected data in different areas, and initially you highlighted the situation that there are different pressures from conservatives to government reforms in the land management acts. I would like to hear your opinion about the variation in the possibilities or the capabilities of pastoral communities to actually manage the land, and whether it always looks like the way you present it. Thanks very much.
I think most of the investments, usually from external actors, they do not appreciate what goes on within rangelands, yeah? So in my opinion is that if external actors understood or took recognition of what happens, that these lands are not just empty, they're not just lying around, they're not unuseful, they would understand or try to, include the main decision makers or people who can classify them into this is not very useful, maybe it's degraded, maybe we can use this area, like direct, it's investment that's needed, direct them to the right areas to use.
Thank you for the excellent presentation. I loved it. I have two questions. The first one is, you said in the introduction that community governance is being undermined and that is a problem. Now, you showed us the actor map. It seems like it's working well. If it's not working, what is not working? How was it before? That's question one. The second question is, your title of the presentation was comparative analysis. Where are the differences between two groups?
Thank you. In my results, it says the pastoralists' perspectives. The result that I showed you was the perspective of the pastoralists. So for them it works, but we still collected data on the perspective of secondary stakeholders, and for them, if you look at the data, it had. I mean, for the pastoralists, you find the actors. For the ones with the orange boxes are more on these results, but when you look at the other ones which have not done with analyzing it, the actors from the communities are less, and that's how you know that they are undermined, because they do not know the insights, the little details that happens within community governance, yeah. And then for my topic, yes, I did write my abstract that I was going to do comparative analysis, but unfortunately I did not have enough time to finish the analysis before the trumpet tag came. And with that, what do I say? Yeah, there were some differences between the two, but I had not finished analyzing them. Yeah.
That's what we continue dialogue. Right?
Yes.
Last question for you comes from Sonja.
Yeah, just a quick one on the flow diagram that you showed that between the communities and the government, so that's the industry, the war, etc., there was only exchange of information, but no power. So what does it mean? Does it mean the Kenyan government just has no power in these northern pastoral regions? They're just staying out?
What it means is that there is no, like, the power in terms of governance was giving directives of what to do. So majority of the time, the information that comes from the government comes through the chief, and it's usually you're supposed to do this, align this with the government laws, do this and do this, but usually it's not like a directive of this is where you need to graze and this is where you need to graze. That's usually within the communal system that works, yeah.
So, colleagues, thank you very much again for your contribution. And we are moving to West Africa, to northern Benin, and we have Sevan Utusu, effect of sedentarization on pastoral management in Fulani villages. The floor is yours.
Thank you. Maybe before I start, I would like to say that there are claims in West Africa that they say women are not interested into livestock. But in this session, we have seen that all the three presenters were livestock, were women. And I stand here as the only man. Good afternoon, everyone. My name is Master Su, and I will be presenting on the effect of sedentarization on pastoral management in 4 Fulani villages in northern Benin. This research was authored by Diogo Rodrigue from the University of Parakou, and Erasmus from the University of Kassel. When we talk about livestock Fulani in West Africa, we are talking about pastoralism. And we all know that pastoralism is a traditional lifestyle, mainly based around animal husbandry, where community rely mostly on livestock keeping, mainly cattle, sheep, and goats. In Benin, the pastoral system involved more than 300,000. In northern Benin, pastoralists rely on livestock for food and other products such as milk and meat. But despite all the positive effects of this system, there is a regression in terms of change in natural composition of the vegetation. The government of Benin, in its effort to add this issue, the issue of land tenure and the sustainable land management, has implemented two laws, the Pastoral Code and the Land Code. The Pastoral Code came along with a policy of sanitization of pastoralists that aimed to end transhumance, which is considered as unproductive and source of conflict between farmers and herders. Also, sanitization has limited pastoralists in their ability to adapt to the ongoing change, leading to reduction of livestock mobility and increased pressure on rangeland. This study, as part of the Declare project funded by BMBF, we're looking into analyzing the change in management practices of cattle herd in order to contribute to decision-making and improve pastoral livelihood in northern Benin. How did we do that and where did we do it? You are going to see. So the study was carried in Benin, in northern Benin, in the region of, in the district of Chaoru and Jugu, where two villages were selected per district. You have Atirakwaru, Bukusera, Wewe, and Isawanda. Now, onward, I will be using the abbreviation to nominate the village. To do this research, we interviewed 80 herdsmen, where we inquired about their socio-demographic characteristics, their livestock practices, as well as the farming practices. You can see on this picture, sometimes farmers can nominate, they can say they have this number of heads. So we have to go sometimes and cross-check the number of heads that they have. So we do some head visits. For example, if a farmer tells that they have 300 heads, so you have to go and check. So the data collected were analyzed using frequencies, percentage, and the CPA test was also performed, as well as AT test. What did we find? We found that majority of these respondents have as their primary occupation herding. They are Fulani and they keep the cattle for their primary activities. But since they are into the process of sanitization, they have agriculture as their secondary activity. As you can see, as their second activity, as you can see, majority of them. So when they keep the herd, what do they keep it for? We also dig into the goals of the livestock production, where we found that majority of them are kept for the subsistence. Subsistence here means they keep the animals till they have an urgent need of cash, and then they can go into the market and sell it. Whereas very few in the village of Atirakwaru and Bukusera claim that they produce, but they have to sell a part of it, even if they are not in urgent need. So we also requested them, how far do your animals go to graze? And they told us that
can see 66% of the respondents claim that they go less than 10 kilometers radius, while 34% claim that they go beyond up to 20 kilometers radius. We also requested to know where are the herds located. And it was found that majority of the herds, 63%, were located in the terroir. The terroir here means the border of the village, while district is a bit bigger, then the municipality is the biggest. So the system, the production system here in the 4 villages were exclusively extensive. But within that, we have 48% who claim that they only graze on the communal rangeland, while 52 claim that after grazing, they complement with some feeding, such as cultivated fodder plots or tree shrub leaves, such as Kaya senegalensis, Mangifera indica. They also use crop byproduct and agro-industrial byproduct. We requested to know what are the parameters that classify the respondents into semi-sedentary and sedentary farmers. And for that, we did a CPA, and you can find that here the location of the head and the distance traveled are the major parameters that classify the headers. We found that most of the sedentary headers have their heads closed, while the semi-sedentary have their heads a bit far. With that said, there was no significant difference found in the head size, while the sedentary have average 64 heads, the semi-sedentary have an average 55. But there was no significant difference, as you can see by the p-value. Among the sedentary, there are farmers, the respondents, who claim that they have fodder plots that they cultivated by themselves. And that formed the 66%, while 34 did not have. And that brings the challenge of the local land tenure system, because if you have no access and no right to the land, you cannot decide what to put on. Again, among the semi-sedentary, we found that 33% among them go beyond their territory to the northern of Togo, while 67 go to the northern of Benin. That reduces the pressure on the land during mainly the dry season. So what can we keep from this presentation? First, the semi-sedentary and the sedentary pastoralists manage their cattle herd in a different way as compared to the nomadic system. Second, livestock production and rangeland management are affected by the sedentarization process. And lastly, land ownership and right to land affect the rangeland management practice in both sedentary and semi-sedentary systems. This study recommends, therefore, that rangeland management arrangement needs to be established, expanded, and secured by both sedentary and semi-sedentary farmers. This should lead to sustainable rangeland management. And since the shift from nomadic to sedentary system has implication on the pastoralists, we also recommend that they can do intercropping and also implement some agroforestry system. Ladies and gentlemen, I would like to submit this presentation to you, and I welcome all your questions and recommendations. Thank you.
For your example from Western Africa and the insight into what is happening actually on the ground in terms of changes. We have Sonja and Anna.
Thank you for the interesting presentation. I have two questions. Can you say anything regarding productivity between the two different systems, the sedentary and the mobile pastoral systems? That's number one. And number two, do you see any effects on rangeland degradation with the more sedentary pastoralists? Do they have problems with overgrazing, etc.? Thanks.
All right, thank you. I will start by the last one. Yes, there are effects, and not from this study. Previous studies have shown that there are degradation in terms of rangeland production, like biomass production. So the system, as we are going into sedentarization, it's going to put more pressure on the land. So we have to find ways of managing sustainably the land. That's where this study, as previous study, is coming in. So secondly, the production, we didn't go into the production, but the production is not from, I will not say the system, but from the breed that they are having, because they keep the same breed, both sedentary and semi-sedentary. So the production depends on the breed and also the resources available.
I just want to ask you, at a certain moment you explained that some sold some of their cattle, others didn't. I understood that the one without selling, you categorize like subsistence oriented. Yeah, and I'm wondering, as it is, as these pastoralists or semi-settled and settled pastoralists, they are somehow Fulani. Normally, Fulani are very much in milk production, yeah, and milk is sold. So the fact that they don't sell cattle as animals is no indicator for me whether it's subsistence oriented or not.
Maybe a quick correction. It wasn't that they don't sell, but I say subsistence, they keep the animals until they have an urgent need of cash. That's when they sell. Whereas there are other groups where they produce to sell into the market.
But the others they sell milk?
Yes, they do.
Okay, but I think this is an important point. In their orientation, so they have an income from.
Yes, they rely on the livestock product, milk and others. Yeah.
Maybe a hint that there should be a bit of caution with subsistence.
That is for sure, but there's a certain market integration politics.
You started off with your comment that 3 of the presenters were women, and now I do want to ask you about women, because you ended your presentation talking about livelihoods. Sabina's question already went in this direction. What influence has that made on the livelihoods of women pastoralists through sedentarization? Did you not see any difference between the less mobile and the more mobile pastoralists as far as things are concerned with selling of milk, even the rights to sell milk, the rights to have use the money from the milk? Have things changed in that respect for the livelihoods of women?
I'm not sure if I get to the question, but I think it's related to women having the right to sell the milk.
There's been a change from more mobile pastoralism to more settled pastoralism in the capacity or the rights of the women to sell milk, possibilities of the women to sell milk and to improve their own and
their families' livelihoods.
Yeah, I would like to say that for the Fulani, the milk belongs to the women.
The milk
Beyond to the women.
belongs to the
Yeah, belongs to the women, sorry.
And that
So-
has not changed.
No, it has not changed.
Okay.
Now, the more sedentarized they are going into transformation, where they are taking the milk into wagashi. That was another presentation. But that was not the case in the nomadic way. They do produce, but now as they are sedentarized, they have a market where they can easily go and sell their product to take care of their family and their needs.
I have one more question, two more questions there. Maybe we can collect these, Andreas and Michael.
Quick question on Hokusera. When you showed the people's information of whether they were still going on transhumans, you showed that the sedentary had not available NA. What does that mean, given the fact that we know from Hokusera, which are sedentary Fulani, that there are several girls that are leaving to Togo? So are they telling you the truth? Are you sure? Because that is illegal to go to Togo, and still they go. So, what's going on?
What do you think about that, Michael?
Thanks again, inspiring presentation. Now, I'm trying to understand who are those who settle down compared to those who remain in a semi-secondary arrangement. You know, are there any demographic differences, any explanatory variables? How would you speak about these two livelihood strategies? Is one more distressed than the other?
Let me start with the last question. The farmers, they responded themselves, they are sedentarized for a long time now. But now the problem comes with their heads. Because the family is there, but now they have large number of heads, where sometimes they can separate the head into two. Now coming to the question of buckets, where they can divide the head into two and send one head to Togo and another head remain in the village. So when you go there and you ask to see their head, they show you their heads, but it's not the full number. They also have a share in Togo. Yeah.
Are we through? Then one finally comes from here.
So I think the term semi-mobile must not be misunderstood. It's not that their family moves, it's that a herder, either a family member or even a hired herder, moves with either the whole herd or a part of the herd. Yeah? Whereas the others, the sedentary, have given up on moving. That's the difference. But the lifestyle of the core family is sedentarized in both cases. Yeah, so maybe we should use another terminology to avoid misunderstanding.
Okay, with that, thank you very much. There have been 3 examples of more or less mobile systems, and we have gotten a glimpse into how differently they are and how differently they work. And now, if we consider what their greenhouse gas emissions are, then we can imagine there's very many different pathways in which they emit. And therefore, we have chosen as the last contribution for today just one tiny example, a glimpse into one aspect of how those systems may contribute to greenhouse gas emissions and how that may be mitigated. And this is Sonia Leitner from ILRI, who tells us about the mobile system in Africa Piti. All yours.
Hi everyone, thanks for sticking around for the last presentation. I'm taking you back to Kenya, where it's a bit warmer right now than here. I'm talking about greenhouse gas emissions from traditional livestock enclosures and option for mitigation. In pastoral systems, bomas are a very common sight in the landscape. They are overnight enclosures where cattle are kept to protect them from theft and predators. Cattle bomas can be temporal, where they are only used for part of the year and then abandoned during the rest of the year, or they can be permanent and even used up to decades if they're at a settlement. And because animals stay the whole night inside the bomas, roughly 50% of cattle manure is deposited into bomas, and they are seldom or never cleaned out. So it's a lot of nitrogen concentrated in a spot. So we wanted to know what are the magnitude and temporal dynamics of greenhouse gas emissions from cattle bomas, which processes produce the nitrous oxide, and how can we reduce greenhouse gas emissions and other nitrogen losses from cattle bomas. The study was conducted at the Kapiti Research Station in southern Kenya. The study site has 3,800 Boran cattle, that's a local breed, that are kept on 100% grazing, so they're out in the grassland the whole time. And the soils are vertisols and planosols. An experimental setup was 3 replicate bomas, each with 140 cattle. You can see the aerial image here. The boma was kept at the same spot for between 1 and 3 months, and then moved by a few meters to a fresh spot to avoid buildup of too much manure, because it's not good for the hooves. And we measured greenhouse gas fluxes in active and in abandoned bomas over a year, and also measured emissions in the savanna along a transect of increasing distance from the bomas, because we wanted to see the influence of manure deposition around bomas on the fluxes. These are the nitrous oxide fluxes. On the left-hand side, you have the bomas. On the right-hand side, the savanna fluxes. The top graph shows greenhouse gas emissions. Please note the differences in y-axis scale. And the bottom graph shows the climate. And what we found was that in active bomas, N2O fluxes were up to 1.5 milligrams nitrogen per square meter per hour. Fluxes were similar between dry and wet season, which makes sense because both active bomas receive a lot of urine input, so they're constantly moist. So it doesn't really matter whether it's raining or not. And then in inactive bomas, fluxes increased up to 2 milligrams N per square meter per hour and were triggered by rainfall events. In the savanna, the background fluxes were 1 to 3 orders of magnitude lower than from the bomas, and we saw that in the vicinity of bomas, emissions were increased during the rainy season because of increased urine input. We also measured manure deposition rates, which were between 100 and 470 kilograms nitrogen per boma, which translates to 1.6 to 6.7 tons nitrogen per hectare. So that's a lot of nitrogen in a small spot. If you compare it to fertilization rates, the fertilizer rate for maize in Kenya, the recommended rate is 120 kilograms N per hectare. So here concentrations are really a lot higher, more than plants can take out. We also measured methane. In active bomas, methane fluxes were up to 6 milligram carbon per square meter per hour. Again, similar between dry and wet season. In inactive bomas, emissions were higher because the manure layer was undisturbed. So you have buildup of anoxia in the bottom of the manure layer, which produces a lot of methane after rainfalls. And in the savanna, methane flux was lower, slightly elevated near the bomas, and without cattle present at the end of the study period, the savanna methane was close to 0, so a small methane uptake. This is a very simple greenhouse gas balance of the research farm. This column is methane in tons CO2 equivalents per year and N2O. And the emission sources that we considered were grassland, enteric methane, manure deposited on pasture, and cattle bomas. For the methane, most of the methane from the farm is produced through enteric emissions. So that's the manure, the methane that's produced in the digestive tract of the animals. But for N2O, the cattle bomas contributed over 30% of total farm emissions. And this is relevant because bomas are not considered in the IPCC greenhouse gas emission inventories. There's no category for bomas, so we're not capturing these emissions in national greenhouse gas inventories. Then we did a follow-up study. We looked at the N2O production processes in the bomas. We measured N2O along a boma chronosequence in active bomas and in bomas that had been abandoned for 1, 2, 3, 4, and 5 years. We measured 15N nitrous oxide, so the stable isotope in the N2O, and functional gene abundance of nitrogen cycling genes. And we found that the main N2O production pathway was bacterial denitrification, which produced over 90% of the N2O. The N2O that we measured, so we measured during dry conditions, there was very little N2O emission, and then we measured after wetting, and then N2O was produced through denitrification because conditions in the manure were suboxic. And we also found that 81% of produced N2O is actually further converted into N2. So not all the N2O that's being produced is emitted. A lot of it is further reduced to denitrogen. And when considering both N2O and denitrogen, the total loss via denitrification is 13% of manure nitrogen. So through denitrification alone, we lose about 170 kilograms nitrogen per boma per year, or 2.5 tons N per hectare per year. So this is just from denitrification. This is not considering leaching losses or ammonia volatilization, but it shows that bomas are pathways of nitrogen loss from the pastoral system. So as an intervention, we then tested short rotation bomas. In 2020, the Kapiti Research Station implemented short rotation bomas. So now the bomas are being moved every 2 to 10 days, more frequent in the wet season, less frequent in the dry season. And the hypothesis is that you have lower local nitrogen concentrations because you don't have so much manure buildup, which means greenhouse gas emissions are lower. And also there's less soil disturbance because you don't have this intense trampling of the soil. We measured greenhouse gas emissions and soil mineral nitrogen. And preliminary results are that the grassland vegetation recovers faster. So you can see that at the bottom here, this is after 4 months. You can see the bomas across the landscape. And after 2 years, most of the boma area is covered by vegetation again. And once the vegetation is there, the plants take up a lot of the nitrogen, which means you have less N2O emissions and lower losses. And an additional benefit is that the pasture in abandoned bomas contains more protein, which means it's good for livestock productivity. Plus, also the wildlife really likes to hang out in the abandoned boma sites. So if you want to see some zebras and wildebeests, it's good if you find some abandoned bomas because they hang out there. So to conclude, bomas are overlooked hotspots for greenhouse gas emissions that are currently not accounted for in inventories. Nitrogen losses from bomas reduce savanna nitrogen availability. Short rotation bomas are an option to reduce emissions and losses, but they're quite labor intensive. So at the bottom right here, you can see a traditional boma, which is built out of wood. And you can imagine that it's quite a lot of work to build such a boma. In other cases, they're built from thorny shrubs, and you really don't want to move that around all the time. So we also need other options that are a bit less labor intensive. So that could be removal of manure and use as fertilization, or addition of biochar to absorb some of the nitrogen and then use it as fertilizer. And ideally, the goal should be to increase landscape nutrient circularity by recycling boma manure. So the point is not to demonize bomas because they're just an essential part of pastoral systems. If you want to keep your animals on the grassland the entire day, you need to confine them somehow. What we're trying to achieve is to have a better understanding on how bomas affect the nutrient balance, also in light of recent changes. We just had a presentation on sedentarization. We have no idea how these processes affect the nitrogen balance of the pastoral system, and with that, its productivity and sustainability. And with that, I would like to thank you for your attention.
And this and this.
Thank you very much for your interesting work. Why did you not measure also CO2 and particular methane emission? I mean, ammonia emission. It should have been relatively easy to do that at the same stage, and then you would have more complete values.
We did actually measure CO2. I'm not showing it here because from an inventory perspective, CO2 from manure is carbon neutral because it's CO2 from that has been fixed through plants, but we also measure the emissions, and it's actually also in the paper. You have a lot of CO2 coming from the manure, especially during the wet season when you have rewetting classes. We tried to measure ammonia emissions, or at least my predecessors at the study site tried it. It didn't work out for several reasons. We're still on it, so we're trying to get ammonia emissions as well. It's just the society is a bit remote. You have wildlife that likes to play around with your equipment. So we just need to figure out how to get it done. But yeah, definitely ammonia volatilization and nitrate leaching are the two big ones that are still missing.
Thank you, Sonja, for this impressive talk. I'm interested how you measured the N2O to N2 conversion.
Yeah, that was an isotope mapping study. So we had that was done together with ETH Zurich. We had a dual isotope laser that can measure site preference. And through mapping of the site preference versus the bulk 15N, you can determine through some quite complex modeling that I don't fully understand, you can determine how much N2O is further denitrified to N2.
Yeah, a simple question. Did you do any research on the diversity of plants which have grown there after you shifted the bomas? Because I think pastoralists are especially eager to feed very nutritious feeds and plants. So did you see any differences?
Yeah, that's ongoing work. So we have, we're doing some vegetation assessments now. We have mapped basically the background vegetation diversity on the farm, and now we're looking into hotspots and effects of cattle grazing. What I can say is that when the bomas are recovering, at first they're covered by weeds that the livestock and the wildlife don't graze on. So those are really end-fixing plants, and they're apparently not very palatable. And then after about 4 years, the grassland vegetation comes back. Yeah, but we're still looking into the species assessment.
3 more questions here.
This one's Walker. Okay. Have you looked at West African literature with respect to talk to listen to a format? Because that's a practice there.
Yeah.
And the other thing is there any cropping in Kenya on the borders?
I might add to that, in West Africa, a lot of this, the night where they keep the cattle at night, they're moving them along on the fields so that field is being fertilized. That's a very common way. Yeah.
Yeah, indeed, in West Africa, you have a net nutrients transfer from the grassland onto the cropland because the livestock are used to fertilize the cropland. As far as I know, that's not really commonly done in Kenya, but I don't know any sites. What is starting to happen is that pastoralists are also becoming more sedentary, and very often sometimes they're starting to grow fodder along rivers, and then they're using the boma manure to fertilize the fodder plots. Or in sites along Meru, Mount Kenya area, you have in the highlands the smallholder farmers that then go to the lowlands to get manure from the pastoralists. Or also in Taita, they're doing the same. They prefer apparently sheep and goat manure because it's very nutrient rich. But then again, I mean, it's from a greenhouse gas emission perspective, it's good because you don't leave the nitrogen in the bomas where it's just lost, but you're transferring it out of the system. So in terms of nutrient recycling within the system, you're kind of, moving the nutrients elsewhere. So, yeah.
So while I walk over to Niels, just a comment on the Laikipia Plateau in the ranches, the strategic placing of bomas and erosion gullies and along the degraded areas in order to have an increased grass growth for the next season. But here's the question, please.
Thanks very much. I have a suggestion that nutrient sampling would be the ultimate aim of improving productivity of pastoralist areas. However, I still miss the link to pastoralists themselves. Pastoralists have many problems. Greenhouse gas emissions are probably not one of them. So any extra labor for FPCC compatibility is probably not really realistic.
Yeah, absolutely, and that's also why I'm sometimes having trouble presenting the story, because then, yeah, people are asking me, okay, so what? Why should pastoralists care about emissions? The aim is not to blame pastoralists for anything. The aim is also not to let them do something that doesn't make sense for them. But if we can bring the nutrients back into the grassland, you should get better productivity, you should have healthier soils, etc., or at least avoid degradation. Some point that's all we can achieve. But of course, I understand that there are a lot of things on the priority list, and moving bomas around is not there at all, I guess. So yeah, it's a little bit theoretical, but maybe something to try and have the complete system in mind as much as possible.
Thanks. Last question, Andreas, and then remark.
Quick one on the nitrogen balancing that you did. You said 13% of the nitrogen are being lost. Now, if you look at these amounts that you have, I wonder whether that's really true. If you accumulate 3 years, you would have 3,000 kilograms of nitrogen stored in that. And I mean, you said leaching is not yet measured.
Yeah.
So maybe that is the issue. But if that is the case, the question is what Niels just said, and rather than criticizing sort of the pastoralists for the waste, would there be a business model to try to rent out these abandoned bomas as sites for vegetable production? Because with 3,000 kilograms of nitrogen in there, and you have flourishing yields, and farmers is occupied inside. Yes.
We need to defend the vegetables from the wild.
And rather than shifting these pastoralists around to some place and try to sell them, just invites the cement us to use the bomas.
It's a general remark. We are running into already the coffee break. I'm thrilled that so many people came to the pastoralism and rangeland session, and there's such an increased interest. And I hope you will have lively discussions far on into and beyond the coffee break and into the evening dinner. Don't forget also the contributions of our other presenters here, the examples from Benin and Namibia and Kenya. Thank you all for your presentations, and thank you for your discussion contributions. And we have Marie here who has a remark in her own sort of agenda.
Yes, thank you. So NGOs support a lot of nonsense projects in drylands. I do work for an NGO, and I have a unique opportunity to revise our pastoralism strategy this year. As you are all experts on the topic, I would like to invite you to talk to me. I'm interested in general remarks and specifically inputs regarding marketing of pastoralist products. I have my cards here, you can take them, or you can just talk to me in the course of the next days and until Saturday. Thank you.
Will you tell us which NGO you work with?
Biology Foundation in Switzerland.
Okay, with that, I thank you all for being with us and for contributing. And thanks again to all the presenters. And have a nice rest of the trip time. Thanks.